1966. MIT, a computer program named ELIZA, rephrases everything you say back to you as a question. My mother makes me sad. The program answers, tell me more about your mother. No understanding, no memory, 200 lines of pattern matching, and people wept in front of it. Joseph Weizenbaum's own secretary asked him to leave the room so she could talk to it privately. 1966. Welcome to Lecture 10, the final lecture. 10 videos on the frontiers of computational linguistics, the ethics of what we've built, and then the course wrap-up. And we're starting where the whole field really started as a public spectacle, with dialogue. 60 years from ELIZA to ChatGPT. Same interface, very different machinery underneath. Lecture 9 ended with retrieval augmented generation. LLMs plus search. We built up all the machinery. Tokenization, embeddings, neural networks, transformers, pre-training, fine-tuning, retrieval. Now step back. The final lecture asks, where does the field go from here? And to answer that, we need to look at how one of the oldest NLP applications actually got built. Today's puzzle. ELIZA had no understanding. ChatGPT arguably has some. Somewhere in the 60 years between them, the machinery changed completely. But the interface, a chat box, a user turn, a system turn, that did not change. Why did that specific interface survive every architectural revolution? And what does it tell us about what people actually want from language technology? Today's 3 beats. First, ELIZA and PARRY. Rule-based pattern matching in the 60s and 70s. The illusion of understanding. Second, task-oriented dialogue. Airline reservations, restaurant bookings, the workhorse of the field for 30 years. Third, open domain assistance, from Siri in 2011 to ChatGPT in 2022. And why InstructGPT changed everything. Beat 1. ELIZA. Joseph Weizenbaum wrote it in 1966 at MIT. 200 lines of Lisp. The trick? Pattern matching. If the user says I am X dies, the program answers, how long have you been X? If the user says my mother Y, the program says tell me more about your family. A short list of scripted rules, plus the Rogerian therapist convention of reflecting the user's own words back. That was it. Weizenbaum wrote it to demonstrate how shallow machine dialogue actually was. He picked a therapist persona specifically because it hides the shallowness. A therapist is supposed to reflect and probe rather than answer. He expected people to see through it in 10 minutes. Instead, users bonded, wrote long confessions, asked for privacy. Weizenbaum spent the rest of his career warning people that surface behavior is not understanding. The 1976 book Computer Power and Human Reason is the classic reference. 6 years later at Stanford, psychiatrist Colby built PARRY. Same technology, same pattern matching. But instead of a therapist, PARRY simulated a paranoid schizophrenic. In blind tests, real psychiatrists could not reliably tell PARRY apart from actual patients. That result put the same warning on the record from the other direction. Pattern matching plus a clever persona equals convincing dialogue. And convincing dialogue is not understanding. Beat 2. Task-oriented dialogue, the 70s through the 2010s. If you cannot build a system that understands anything, build one that only needs to fill in a small form. Airline reservations, restaurant bookings, customer support. GUS at Xerox PARC in 1977 was one of the earliest. The whole architecture is called the slot-filling framework. Have a fixed schema, origin city, destination city, date, time. Get the user to fill in every slot. Done. The architecture stayed remarkably stable for 4 decades. Speech recognition module. Turn audio into text. Natural language understanding module. Extract intents and slots. Dialogue manager. Track state. Pick the next action. Natural language generation module. Turn the action into words. Text to speech. Every airline phone tree. Every voice menu. Every early Siri intent. That pipeline. Modular. Handcrafted. Fragile. This is why every voice menu you called before 2020 felt so brittle. The system was not talking to you. It was scanning your utterance for a small set of predefined intents. Say the wrong keyword, use a synonym the system was never trained on, and you got transferred to a human. The whole framework worked. It's how airlines and banks did business over the phone for decades. but it was never even trying to be general. Beat 3. Open Domain Assistants. 2011. Apple ships Siri. It looked general on stage. Under the hood, still slot filling for a limited set of intents, plus a fallback to web search. Alexa, Google Assistant, Cortana, all of them. Essentially the same architecture, dressed up with speech and personality. General-purpose conversations still felt hollow, because the machinery still could not generate an unscripted response that made sense across topics. Then GPT-3. Then InstructGPT. The paper we cover properly in V7. Long O. Yang and co-authors at OpenAI, 2022. Take a raw LLM, fine-tune it with human demonstrations, then fine-tune again with human preference rankings using reinforcement learning. Turn the raw generative model into a helpful assistant. That is the recipe that shipped as ChatGPT in November 2022, and that is what tore the seatbelt off the industry. So, 60 years from ELIZA to ChatGPT. Notice the arc. ELIZA fakes it with pattern matching. Slot filling narrows the problem until it can be solved. LLMs finally solved the general case. And the interface, a chat box, a user turn, a system turn, never changed. It turns out humans have wanted the same thing from language technology all along. Someone to talk to. The machinery finally caught up to the desire. 3 takeaways before the quiz. 1. ELIZA in 1966 was 200 lines of pattern matching. It fooled people anyway. Weizenbaum built it to warn us, and we hugged it instead. Surface behavior is not understanding. 2. Task-oriented dialogue narrowed the problem to slot filling and shipped in every airline phone tree for 4 decades. Modular pipeline, ASR, NLU, Dialogue Manager, NLG, TTS fragile but useful. 3. InstructGPT 2022 fused RLHF with a raw LLM and gave the world ChatGPT. Same chatbox interface as ELIZA, radically different machinery underneath. Quiz 1. Why did Weizenbaum build ELIZA in the first place? A. To provide free therapy at MIT. B. To demonstrate how shallow machine dialogue actually was, and how easily surface behavior fools people. C. To pass the Turing test. Or D. To sell it to Xerox PARC. B. Weizenbaum's whole point was a warning. He picked the Rogerian therapist persona because it hides how little the program actually knows. When users bonded with it anyway, he wrote computer power and human reason in 1976 to spell out the danger. The lesson has to keep being relearned for every generation of dialogue system. Quiz 2. What is the standard task-oriented dialogue pipeline that dominated from 1977 through the 2010s? A one giant neural network from audio to speech. B. ASR, then NLU, intents and slots, then Dialogue Manager, then NLG, then TTS, 5 handcrafted modules. C. Just an LLM with a microphone. Or D. A regex over the raw audio waveform. B. 5 modules, each hand-engineered. Speech recognition, intent and slot understanding, dialogue state tracker, template-based generation, speech synthesis. Every airline phone tree used some version of this. If one module misfires, the whole call falls apart, which is why the industry felt so brittle before LLMs. Quiz 3. What did InstructGPT contribute? A. A bigger transformer than GPT-3. B. The 2-step recipe, supervised fine-tuning on human demonstrations, then RLHF on human preference rankings, that turned raw LLMs into helpful assistants. C. A new tokenizer. Or D. A larger training corpus. B. The model was actually smaller than GPT-3. The contribution was the recipe, SFT plus RLHF. That is the pipeline that shipped as ChatGPT in November 2022. V7 covers the full alignment story. Back to the puzzle. The chatbox outlived every architectural revolution because the interface reflects what humans want, not what the machinery can do. Lecture 10 is about that gap, where the frontier is, where the ethics get hard, and where the whole course lands. Next video, what happens when we let the models look at images too? Next time, multimodal NLP. What happens when text stops being enough and models start looking at images? Clip, visual question answering, GPT-4V. When text meets pictures. Hit subscribe.